On February 28, General Atomics Aeronautical Systems announced that following the XQ-58A, the second-generation autonomous collaborative platform XQ-67A unmanned aircraft for the U.S. military successfully completed its maiden flight in Palmdale, California. What impact does this have on the development of U.S. military drones and manned/unmanned aircraft collaborative operations? Is there still room for traditional drones like the MQ-9?
The Air Force Research Laboratory, AFRL, has achieved a significant milestone with the successful first flight of its XQ-67A demonstrator, part of the second generation of Autonomous Collaborative Platforms, ACP. This breakthrough occurred on February 28, 2024, at Gray Butte Field Airport in Palmdale, California. Developed under the Offboard Sensing Station, OBSS, program, the XQ-67A represents a major advancement in unmanned aerial technology. The OBSS program introduces an innovative approach to aircraft design and production. The XQ-67A is built on a standardized chassis, or genus, similar to a vehicle's frame. This common framework allows for faster and more cost-effective replication of the aircraft, ensuring that advanced capabilities are delivered to the warfighter swiftly. This approach meets the increasing demands of great power competition by rapidly bringing cutting-edge technology to the field. Constructed by General Atomics, the XQ-67A exemplifies AFRL's commitment to rapid innovation. The demonstrator was designed, built, ground-tested, and flown within just over 2 years, highlighting AFRL's strategy to maintain technological superiority. The XQ-67A complements other AFRL projects such as the XQ-58A Valkyrie, the X-62 Vista, and the F-16 Venom efforts, all aiming to expedite the deployment of collaborative combat aircraft, CCA. The XQ-67A first flight included several test points and successfully completed its mission, marking the beginning of a series of flight tests to further validate its capabilities. One of the notable features of the XQ-67A is its ability to operate both under remote piloting and autonomously. This flexibility is crucial for modern combat scenarios that require quick adaptation to changing environments. The XQ-67A development is part of AFRL's low-cost attritable aircraft platform sharing (LCOPS) program, which focuses on creating a core architecture, or genus, from which various species of aircraft can be developed.
In 2021, General Atomics began the development of the XQ-67A after securing a contract from the U.S. Air Force Research Laboratory. During the initial design phase, they incorporated the concept of the low-cost attritable aircraft platform sharing program proposed by the AFRL. The AFRL pointed out that the first-generation autonomous collaborative platform, the XQ-58A, couldn't simultaneously fulfill the mission concepts of the LCOPS program, namely the Offboard Sensing Station and Offboard Weapon Station. The former focused on long endurance, while the latter emphasized high-speed maneuverability and improved range. The application of the common carriage allows for the construction of multiple aircraft variants by combining different aerodynamic designs and system suites, thereby enhancing the collaborative operational capability between manned and unmanned aircraft in the U.S. military. It also enables rapid design and production of aircraft by combining standard components and subsystems, leveraging logistical commonality advantages to save production costs and time. Trenton White, the LCOPS and OBSS program manager, expressed affirmation, stating that the XQ-67 is the first U.S. model designed and manufactured based on the concept of a common platform, validating the concept of open hardware and software aircraft systems. This will achieve low cost and rapid response for U.S. military fighters. From the released images, the XQ-67A bears the markings of General Atomics and the AFRL, and it has a tricycle landing gear layout. The entire aircraft is designed with a stealthy configuration, featuring a dorsal air intake, small swept-back wings, and a V-tail combination. It appears to share some similarities with the MQ-9, MQ-25, and XQ-58A. With the conclusion of its maiden flight, more details have been revealed. Based on existing information, the XQ-67A is expected to focus on air-to-air combat and infrared surveillance and tracking missions, enabling manned and unmanned aircraft cooperation in air superiority operations. It falls under the category of an off-board sensing station unmanned aircraft, OBSS. Prior to the introduction of the XQ-67A, General Atomics had been using the MQ-9 unmanned aircraft, paired with pod-mounted IRST sensors, to attempt to build an airborne surveillance and early warning system for the U.S. Air Force's future distributed air radar surveillance system. However, it seems that the XQ-67A has now taken on the role of a pioneer. The choice of an IRST sensor is due to several reasons. Firstly, IRST is not affected by radio frequency interference and can detect stealth targets that radar may not be able to see. This is particularly important in today's increasing prevalence of stealth aircraft. Secondly, IRST can passively scan threats without emitting any electromagnetic radiation, greatly reducing the risk of detection. If multiple XQ-67A unmanned aircraft are equipped with pod-mounted IRST sensors and flown in a networked manner, they can perform triangulation on potential threat targets and transmit the location information to strike units such as fighter aircraft and air defense systems for engagement. Of course, the XQ-67A unmanned aircraft can also be equipped with other sensors, such as modular radar and electronic surveillance measures. This allows the unmanned aircraft swarm to function as a distributed sensor or electronic warfare node and communication relay, enabling collaborative operations with manned fighter aircraft and even conducting suicide attacks. It is worth noting that General Atomics, although not explicitly linking Gambit and OBSS, both utilize the common core concept. Additionally, General Atomics has referred to the OBSS unmanned aircraft concept image as Gambit 2. The concept of Gambit was first introduced by General Atomics in 2022. It is an autonomous collaborative platform. The first phase of the ACP program, the Skyboard project, involved integrating an autonomous control system into low-cost attritable unmanned aircraft, such as Kratos' XQ-58A Valkyrie, to demonstrate the feasibility of integrating the autonomous control system with multiple low-cost unmanned aircraft platforms. The second phase of the ACP program, the OBSS project, took it a step further by integrating the Skyborg autonomous control system into a more advanced unmanned aircraft platform with a sensor suite capable of executing combat missions, validating the feasibility of the common carrier. According to General Atomics, each model of the Gambit series unmanned aircraft, Gambit 1 to 4, features a central physical core structure to which the rest of the aircraft is connected. This common hardware is known as the Gambit core and includes the landing gear, baseline avionics, chassis, and other essential functionalities. It is said that the Gambit series unmanned aircraft, along with Kratos' Demigorgon drone, competed for the OBSS project. General Atomics describes Gambit 1 as focusing on long-endurance sensing and being capable of manned/unmanned collaborative operations or long-range patrol missions. However, it will not carry weapons and will only serve as a node for surveillance, targeting, and communication relay, similar to OBSS. This shared core concept of the Gambit or OBSS unmanned aircraft is crucial for the future of the U.S. Air Force in achieving air superiority. Will it be part of the U.S. Air Force's CCA program? And how is the progress of the OBWS, which was introduced alongside OBSS? First and foremost, it is important to understand that the CCA program affects the operational effectiveness of the U.S. military's next-generation tactical aircraft. It can serve as a long-endurance situational awareness platform, a sensor and strike-integrated platform, an air combat training platform, and a stealthy penetrating reconnaissance platform. In March 2023, the U.S. Secretary of the Air Force, Kendall, directly stated that the future U.S. Air Force fleet will consist of 200 NGAD aircraft, 300 F-35As, and at least 1,000 CCA unmanned aircraft, replacing the current tactical aircraft in service. This means that each F-35 or NGAD aircraft will be equipped with 2 CCA unmanned aircraft. However, in recent years, the high cost of U.S. military weapons has already caused dissatisfaction among senior U.S. officials. Although against strong opposition from the U.S. Air Force, the U.S. National Defense Authorization Act ultimately removed the legislative provision imposing cost limitations ranging from $30 to $250 million on various levels of CCA projects. Nonetheless, members of Congress still demand that the U.S. Air and Navy forces explain how they will reduce the cost of CCAs in the future. According to their requirements, the Secretary of the Air Force and the Secretary of the Navy need to provide a separate report on the CCA to the Congressional Defense Committee by May 1, 2024. The report will include the definition of affordable cost for the CCA program and how to determine if such unmanned aircraft are suitable for consumable tasks in future conflicts. The Common Core approach of the OBSS project not only fulfills the various operational requirements of CCA unmanned aircraft in future air combat, but also reduces maintenance and production costs through logistical commonality advantages. As for the OBWS project, according to the AFRL's release, some work on OBSS and OBWS was done in parallel. However, due to secrecy, it is currently unclear whether OBWS has entered the flight testing phase like OBSS or has signed contracts for the development of actual OBWS aircraft. But it is certain that the significance of OBWS development will be equally important as OBSS. While OBSS has achieved a distributed surveillance system for the U.S. military, OBWS is expected to further facilitate distributed and swarm operations, advancing the modularity of unmanned aircraft and their collaboration with manned aircraft in the U.S. military. This raises a new question. Now that there are new unmanned aircraft like the XQ-67A, do traditional drones like the MQ-9 still have a place and value? Certainly, they still have value. Despite the fame of the Skyborg project as the most well-known manned/unmanned collaborative warfare project in the U.S. military and the introduction of new unmanned aircraft like the XQ-67A, traditional drones like the MQ-9, which can operate in low-threat areas, still have a place. First, there is the matter of quantity. The U.S. Air Force currently has over 280 MQ-9 drones in service, which are much younger in age compared to the active fighter aircraft. Phasing them out and retiring them would not only result in wastage of resources, but also lead to a significant decline in the combat capabilities of the U.S. Air Force. Second, although the MQ-9 can only operate in low-threat environments, modern warfare, even in conflicts like the Russia-Ukraine battlefield, is not entirely high-threat. The MQ-9 can still participate in various mission operations. Lastly, the MQ-9 is the most numerous unmanned aircraft platform in active service for the U.S. military. It is the only platform capable of providing high-altitude, long-duration intelligence, surveillance, and reconnaissance, and conducting strikes when necessary. In operations such as strikes against the Houthi rebels in Yemen, the U.S. military would prefer to have more MQ-9 drones. It would be impractical to retire them. Of course, some U.S. officials believe that the operational concept has shifted and drones that can only survive in low-threat environments should be phased out. They argue that the funds allocated for upgrading MQ-9 should be redirected to more pressing areas such as hypersonic missiles, CCA, OBSS, and other projects. The U.S. Air Force has considered replacing the MQ-9 with a stealthy unmanned aircraft for operations in high-threat environments. They have issued a request for information, seeking industry insights on such an aircraft. The idea seems to be absorbing the capabilities of the MQ-9 into a broader concept, including the MQ-Next. However, the RFI is far from reaching the stage of a specific project, and there is currently no funding support for this work. Its prospects remain uncertain, so traditional drones like the MQ-9 cannot be replaced in the short term. Instead of considering retiring the MQ-9, the U.S. Air Force should increase investment in the platform and upgrade it. Through moderate modifications, it can acquire the capability to survive in high-threat environments and perform multi-mission operations. By improving and equipping it with different devices, it can execute tasks such as communication relay, wide-area surveillance, and missile warning. In summary, the U.S. has both traditional drones like the MQ-9 to fall back on and innovative new unmanned aircraft like the XQ-67A in its manned/unmanned collaborative warfare efforts.